What is going on, everybody? Got another video here for you. This one is derivatives and integrals of vector functions. So let's go ahead and get started. All right, so we've got the derivative of vector r with respect to t, which we can write r prime, vector r prime of t is equal to the limit of vector r of t plus h minus vector r of t over h. We take the limit as h goes to 0. So you probably recognize this. This should look familiar from Calc 1 when you did the definition of the derivative. You took the limit as h goes to 0 of f of x plus h minus f of x divided by h. All right, so it says the vector r prime is called the tangent vector to the curve defined by vector r at the point P, provided that r prime exists and r prime does not equal 0. The tangent line to C at P is defined to be the line through P parallel to the tangent vector r prime of t. And then we have the unit tangent vector is vector t is equal to vector r prime over the magnitude of vector r. All right, so we'll use this later on when we work an example. All this terminology here. All right, so we have a theorem if vector r is equal to f of t, g of t, h of t, which equals f of t plus times vector I plus g of t vector j plus h of t vector k, where f, g, and h are differentiable functions. Then r of t, vector r of t, then, that is wrong, vector r prime of t is equal to f prime of t, g prime of t, h prime of t, or we can write it in this ijk format. So basically what it's telling you, if you have a vector r here, to find the derivative, you just take the derivative of each function. All right, so let's look at some examples. So it says find the derivative of vector r, and here's vector r, and then for part B they want us to find the unit tangent vector at the point where t equals 0. All right, so let's see what we get. So let's just rewrite the vector r of t. That's 1 plus t cubed times vector I plus t e to the negative t times j plus sine 2t times vector k. All right, so the derivative we get, so we're just taking the, I don't know why I wrote that like that. That'd be a parenthesis there. So all we're going to do is take the derivative of each one of these. There's f of t, g of t, and h of t. And so this is going to be 3t squared times vector I plus, now on this one, we've got to use the product rule. So the derivative of the first function, which is 1, times the second function, plus the derivative of the second function, which is e to the negative t, times negative 1, times the first function. Okay, so that's the derivative of this one, and times vector j, plus the derivative of sine is cosine, so that's going to be 2 cosine 2t times vector k. And so we get r prime of t is equal to 3t squared times vector I plus, okay, so for this one, we can factor out a common factor of e to the negative t, and that is going to leave us with 1 minus t e to the negative t times vector j plus 2 cosine 2t times vector k. And so there's the derivative. of vector R. All right, so now this is part A, and for part B, they want us to find the unit tangent vector. All right, so at where t is equal to 0. Okay, so we're looking for t of 0, which by the formula, let's see, where's that formula? Right here, this formula right here. All right, so that's going to be r prime of 0 over the magnitude of r prime of 0. All right, so let's find r prime of 0 and the magnitude of r prime 0. So we have r prime of 0. So all we're going to do is we're going to plug 0 in for t up here. And so when we plug, well, let's just show it. 3 0 squared, times I plus 1 minus 0 e to the negative 0 times vector j plus 2 times cosine 2 times 0 times vector k. And so I get r prime of 0 is equal to, that is going to be j plus 2k. Okay, so that goes out, that's 0. This is 1. And then cosine of 0 is 1, so 1 times 2 gives me the 2. And then I need the magnitude of r prime of 0. So that's going to be the square root, and that's going to be 1 squared plus the 2 squared, which is the square root of 5. All right, so now we get this is equal to j plus 2k over the square root of 5. So we get the unit tangent vector at 0 is 1 over square root of 5 times vector j, not I, plus 2 over square root of 5 times vector k. And this is square root of 5. And so there's your unit tangent vector at t equal 0. All right, so that's easy enough. Not really doing much different, just some more formulas we got to know. All right, so let's look at this one. It says for the curve r of t equals square root of t times vector I plus 2 minus t times j. Find r prime of t and sketch the position vector r of 1 and the tangent vector r prime of 1. All right, so basically what we're doing here is we have to evaluate r at 1 and r prime at 1, and we're going to sketch the function too. All right, so let's find the derivative first. So we got r prime of t. All right, so we're taking the derivative of square root. There's a little shortcut you can do for finding the derivative of square root. So whenever you're taking the derivative of square root, it's 2 times whatever the square root is. That goes in the denominator. And then in the numerator, it's the derivative of what's underneath the square root. So the derivative of t is 1. And so there's your derivative. Well, not plus. How about minus? That's minus 1. J, derivative 2 minus t minus 1. All right, so now let's see, we've got, let's see, I accidentally opened something. All right, so we've got r of 1 is equal to square root of 1 I plus 2 minus 1 j. And so r of 1 is equal to I plus j. And then r prime of 1 is 1 over 2 square root of 1 minus j. Whoop, I forgot the I in there. So r prime of 1 is equal to 1/2 I minus j. All right. So now let's sketch the curve, and let's sketch the position vector r1 and the tangent vector r prime 1. All right. So let's sketch this curve. So from this right here, this r, we can see that x is equal to the square root of t and y is equal to 2 minus t. So if we square both sides over here, that gives us x squared equals t. So we can write y equals 2 minus x squared. And you can see this is just a parabola. Let's see, 1, 2, 1, 2, 1, 2. Trying to make them as evenly spaced as possible so we can get a kind of a good picture of it. So the graph of this parabola y equals 2 minus x squared, that's a parabola that opens down, right? Vertex is at 0, 2, and it crosses at square root of 2, so that's somewhere between 1 and 2. All right, so the vector r1, well, we've got that right here, and we've got r prime 1 is right here. So if we sketch r, that's 1, 1. Okay, so this is r of 1. This is the point 1, 1. And then if we sketch r prime of 1, that's 1/2 negative 1. So 1/2 negative 1, which is right here. Okay, and then we can move this vector, the initial point of this vector right here. So this is our r prime of 1. And there's the sketch of it. All right, so there's that example. All right, let's look at this one. Find parametric equations for the tangent line to the helix with parametric equations that x equal to cosine t, y equals sine t, z equal t. And I did leave one thing out when I wrote this problem with parametric equations, that at the point 0, 1, pi over 2. Okay, all right. I didn't write all the problem down. All right, so we want to find the parametric equations for the tangent line. All right, so let's write down r. So r is the vector 2 cosine t, sine t, and t. And then we're going to need to take the derivative. So we got r prime of t is equal to, that's going to be negative 2 sine t cosine t 1. All right. Now we want to write the parametric equations for the tangent line at this point right here. All right. So from this we can see that t is equal to pi over 2. Okay. So remember, this point here is x, y, z. And what does z equal? Z is equal to t. So that tells us that t is pi over 2. All right. And so now we have r prime of pi over 2. That is going to be, let's see, negative 2 times the sine of pi over 2 cosine pi over 2 1. And so that is going to be negative 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. And then this is just 1. All right. So what do we have here? Okay. So to find the parametric equations, we need a parallel vector, don't we? Okay. And we got our point. So we have our tangent line goes through the point 0, 1, pi over 2, and it's parallel to the vector, where is it, negative 2, 0, 1. All right. So now we're ready for our parametric equation. So we've got x is equal to, all right, so we've got the tangent line through this point. So remember, it's this coordinate 0 plus this number times t. So minus 2t. Y is equal to this coordinate 1 plus this 0 times t, and then z is equal to the pi over 2 plus 1 times t. And so I get x is negative 2t, y is equal to 1, and z is equal to pi over 2 plus t. And there's your parametric equations for the tangent line. All right. So, you know, this right here just goes back to what you did earlier when you found equations of lines and all that stuff. Okay, you might have to go back and review. It'll be the chapter before this one, more than likely. In the Stewart book, this is chapter 13, and that other stuff, the equations of lines and all that stuff, I believe is chapter 12, something like that. All right. All right, so we have a theorem. Suppose u and v are differentiable vector functions, c is a scalar, and f is a real valued function. Then the derivative of u plus v is derivative of u plus v. And I'm not going to say vector every time, so you know what I mean. You got the little arrows over, so you know they're vectors. It's just saying we can take the derivative of each vector. And then this one, c times u, the derivative, that's just showing that we can pull a c out. We can take the derivative of u and then multiply it to c. And then we have f of t times vector u. Now, f is not a vector, it's a function. So that's just going to be the derivative of the function times vector u plus the function times the derivative of vector u. And then we have the derivative of the dot product. That's the derivative of u dot vector v plus the dot product of u and v prime, the derivative of v. And then we've got the derivative of the cross product. That's the cross product of u prime and v plus u and v prime, the cross product of u and v prime. And then vector u of f of t, that's f prime of t times u prime of f of t. And kind of think of the chain rule there. All right, so let's look at some more examples. So these are just your, some properties for derivatives. Okay, you got some product rules right here. See those? All right. So let's look at this. It says show that if the magnitude of r is equal to a constant c, then vector r prime is orthogonal to vector r for all t. All right, so let's think about that one for just a second. So how can we show that two vectors are orthogonal or perpendicular. Well, that's what showing that their dot product is equal to 0, right? All right, so let's start off doing this. So let's start off with r of t squared equals c squared. Let's square both sides. So this means that r of t dot r of t is equal to c squared. So this is the same thing as this. All right, so this is equal to this. All right, so now what we want to do is we want to take the derivative of both sides. So the derivative with respect to t of r of t dot r of t is equal to 0. Okay, so I'm taking the derivative of the left-hand side and the derivative of the right-hand side. Well, c squared is just a constant, so the derivative of a constant is just 0. And so what about the derivative of this right here, r dot r? Well, that's this one right here. See, we're going to use this. All right, so that's going to give me r prime of t dot r of t plus r of t dot r prime of t is equal to 0. All right, so now I can combine these two terms. These are like terms. So this is going to be 2 times r of t dot r prime of t equals 0. And then if I divide both sides by 2, I get r of t dot r prime of t equals 0. So this means that r of t is perpendicular to r prime of t. All right, so that's showing that proved that. All right, so that wasn't too bad. All right, so now let's look at the definite integral. So the definite integral, we have the integral of vector r of t dt is the limit as n goes to infinity, summation I equals 1 to n of vector r of t sub I star times delta t, which is equal to the limit as n goes to infinity. And basically we're summing, because remember r of t sub I star, that's going to be f g h, and so you see we're just breaking it up. So we've got the integral r of t from a to b. We just integrate each function. It's kind of like, think about when we were doing the derivative. We took the derivative of each function. So what we're going to do here is we're going to integrate each one. And then of course we know if we integrate, we get big R of t from a to b. It's just big R of b minus big R of a, where r is an antiderivative of little r. Okay, so that means if we take the derivative of big R, that's going to give us little r. And we use this notation for indefinite integrals. All right, so let's look at this. Wow, this is the last example. This video went pretty quick, didn't it? All right, so it says if r of t is equal to this, find the integral of r of t dt and find the integral of r of t dt from 0 to pi over 2. All right, so let's integrate. R of t first. All right, so this is going to be the integral of 2 cosine t dt times vector I plus the integral of sine t dt times vector j plus the integral 2t dt times vector k. So I'm just integrating each one of them. See, all I did is I used this. See, we just use this property right here. Okay. And there's another thing that I want to mention after we work this problem, so stick around for that. All right. So if we integrate this, this is just going to give us, well, antiderivative of cosine, that's going to be 2 sine t times vector I. We integrate sine t, that's negative cosine t times vector j plus t, well, I wrote an x, plus t squared times vector k plus our constant vector. Okay, and so here is your answer to this problem. All right, so now let's do 0 to pi over 2 of r of t dt. Let's see what that equals. All right, so, I mean, basically all we're doing, we're evaluating this. This is going to be 2 sine of pi over t minus 2 sine of 0, okay? So if we plug the pi over 2 in for t, sine of pi over 2 is 1. 1 times 2 is 2, so that's 2 minus, and then we plug the 0 in. Sine of 0 is 0, so that's 0 times vector I minus, and then if we do the cosine of pi over 2, cosine of pi over 2 is 0 minus, and then the cosine of 0 is 1 times vector j plus, and then we plug in pi over 2 in for t. That's going to be pi over 2 squared minus, and then we plug the 0 in, 0 squared times vector k. And so this is just going to give me 2i plus j plus pi squared over 4 times vector k. All right, and so there's your integral right there. All right, so one thing I forgot to mention up here when we were doing these derivatives up here. So the one thing, you know, that I want you to remember here is you can also do not just the first derivative, but you can do the second derivative and so on. Okay, you can do the second derivative of a vector function, and that's gonna come up in the next section when we do the when I do the video on arc length and curvature. Okay, so yeah, that's all this video. This was actually a short one, but you know, I hope you enjoyed it. Hope you learned something. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I will see y'all in the next one. Later.